I'm gonna try not to trigger you, but I'll be honest, I've been practicing. And I'm gonna do some stuff today with my 5090 board that I want to not fix, but kind of update. And I'm gonna kind of show you guys what I learned along the way. So please, try not to be too triggered, but at the same time, I'm open to your guys' suggestions and how to learn and get better, because I am improving, but we've got a long way to go.
Hey, Jay. Jay. Jay.
What?
We got work to do.
Yeah, I'm playing World of Warships. Yeah. World of Warships is the free-to-play naval strategy game where you command the most iconic and famous warships from World War I and World War II, recreated with stunning detail and accuracy. Build your fleet while participating in various game types while upgrading your ship's arsenal along the way. New players who sign up using my link below will receive an exclusive starter pack to get you up and running quickly by receiving 7 days premium time, 1 million credits, 300 doubloons, and the Tier 5 premium ship, the Exeter. So what are you guys waiting for? Start sinking ships with World of Warships by heading to the description below and getting your freebies. So I've been practicing on this guy. This is actually a 1050. The card that I did the spraying the water on to see how much water abuse it could take before it died. And I was like, can I deal with removing a memory chip? You know, and as you can see, it got a little hot. It got a little toasty. I accidentally knocked off every frickin' SMD around it. Was able to get it resoldered and reattached. And I was very disappointed in how it turned out. But I'm pretty pleased on how this one turned out. I actually removed and replaced that one as well. Can't test to see if it works or not, because it's broken. But it's reattached, and it's straight, and it's centered, and I reballed it, and it floated and stuck itself down. So, you know what actually really helped was this piece of advice.
Heat the board! Heat the fucking board!
Which is why I now have a double hot plate right here. So the stuff I'm using here is not professional grade, it is Amazon grade, but I am about Amazon grade quality myself. So yeah, it does help quite a bit, honestly, to get heat into the board. So here's what we're gonna do today, just to kind of show you guys some of the improvements I've been making. I'm going to be desoldering my EVC controller wires here that I'm using on the 5090 for voltage and line load control. And I'm tired of having it permanently affixed. There's times I might need to throw the air cooler back on here for some sanity check or testing or whatever. So what I'm gonna be doing today is I am going to be, hopefully, soldering on this junction, if you will, onto the post right there, or basically through the through holes, so that I can now be able to quickly connect and disconnect wires from this thing. So that is the goal for today. And it's kind of a fun way to show how much, the idea of heating the board really works, because soldering the ground wire on here was always extremely difficult to get it to stick because of the fact that the ground plane is the entire board basically, and it's multi-layered in copper. So the heat would just wick away as fast as I was trying to heat it. And so by heating the board now means that it can actually hang on to heat better, which means now it's actually very, very quick to respond and do things. So that's what we're gonna do today. So anyway, this board heater, I say board heater, it's really nothing more than a hot plate. That's all this is. It's just, you need a way to get heat up through the board. And I have a piece of silicone somewhere around here because I ended up going with the double wide. That way, if I'm doing, a GPU, I don't have to worry about just focused heat, although I probably only need to put heat right here, to be honest. What I tend to do is just put lower heat on the left side like this, because if the heat is wicking away, but then obviously I need to have the more focused heat right above or right below where I'm working. Here it is right here. So I just tore off one of the little silicone flaps, if you will, on my Amazon soldering station deal, because I have these wires on the backside, which is for my voltage monitoring tool. I clearly, is that wire about to pop off? No, that's just the thermal pad that's stuck there. I clearly don't want to melt the wires by having them sitting on that. So what I was doing was I was just kind of using this guy right here as a little silicone insulation so that those wires are safe. But what I need to do right now is desolder those and get everything ready to go here. So I know I'm well aware that pointing the camera at a monitor is not the best way to show you guys this. Using video capture would be best, but we're in a little bit of a hurry today, so this is what we've got. But if I decide to do more soldering videos showing you guys how I'm trying to learn, then I will do a capture card setup where you guys can, you know, see better what I'm doing. Some things I'm not happy with about this, you can see it's really clean though, right? That's the ground wire right there. It's pretty clean. This is my signal wire for the controller. I'm not happy with the way my wires kind of started to unfray right there. That one actually turned out pretty good. But there's definitely some work that needs to be done. So I'm gonna warm the board, warm these up, pull these wires out, clean the solder off with the solder wick, and then hopefully we'll get this guy on there. And it just happens to be perfectly spaced, which is kind of nice. And again, this all came with the EBC. So let's do this. I'm gonna heat up my board. I'm going to set, I know it's kind of hard for you guys to see. I'll turn a little bit here. 999 is a bad temperature. We don't want that. There we go. It's currently set to 120. That's a little warmer than I think I'm gonna go. I'm just gonna go down to 100 Celsius. And then on this side of the board right here, I'm just gonna set this to like, I don't know, 80 Celsius. It's a little colder than I'd been working with, but I do think I had been working with a little bit too much heat, to be honest, because of the fact that I was dealing with every time I would put my flux on there, it just started to kind of boil. So obviously the board was getting too warm. But I also changed a few things. One, the type of flux I'm using a more liquid flux right now. The only thing I don't care about this flux, and you guys can maybe explain why this is happening, if I work with it too long and I let it get too hot, it gets gummy. Like it kind of gets like sticky. I find that the rosin paste flux tends to be less sticky, but it's obviously a lot thicker. So it'll be interesting right now to see how this goes. But I think I've been using too much flux. Many of you said in previous videos, there's no such thing as too much flux. But I was dealing with too much flux because it was kind of getting everywhere and getting sticky. It was getting sticky on my tweezers. It was getting like, it was turning brown everywhere. Obviously the brown is because of the oxidation that we're dealing with the iron and the solder. But I do think there was such thing as a little bit too much. Anyway, board is warm. Board is already warm. It's crazy how fast the heat works through. All right, let's get my solder station on. Just put a tiny bit of the flux on there. There we go. There. So that's clean. That's a pretty clean removal, I think. Okay, see, that came right off. Yeah, definitely just need more temperature in here. Okay. This tip should hopefully not stick. See, it was just a tip problem. The other tip was too fine, so it was real focused heat. This one, as you can see, is much more flat. So I need to get that solder out of there though, because I need to get those holes opened up now so I can get the pins pushed through. So I'm going to put a little bit of fresh flux on there. You see it turn brown because there's oxidation, obviously. About a little more in there. Still a little bit in that ground wire. Like one tiny little solder ball in there. This is crazy. It's like, it's down in there, so like the wick can't even touch it. All right, so there's that. All the solder's out. Here's my 3-pin connector. So that'll go in there like that. Now I gotta solder this from the back side. And that sort of sucks because it sits kind of far off of the hot plate. So that means I'm not gonna be able to get that much heat into that ground. But I'm just gonna have to try. So got my iron on. One. There's 2. Okay, ground, are you gonna cooperate with me? Oh my gosh, it did. Look at that. It was like the easier one. Okay, these can be cleaned up a little bit though. It's a little bit of extra solder on there, I think, than what we really need. But more importantly, we got a solid connection on there. So that means technically I could use this end if I wanted. Make sure plugging it, unplugging it makes it not pop off. This is not the right connector, but see, I could use that connector like that and just repin both ends if I wanted. But I think what I'm gonna do, simply because I can, is turn this guy off. I don't need that anymore. I'm trying not to burn myself right now by moving it out of the way. Make sure nothing's near it that can melt or kill us. But what I think I'm gonna do right now is just solder, so I've got these guys here, so I can take a green wire, a white wire, and a black wire, and then I can just solder them to their matching colors on this end. Clean these up. There. It's a little pokey, a little exposed, meaning there's a lot of wire showing. But you know what? I'll take it, because I always found soldering wire to be hard to me. Now, if I wanted to do this really nice, I could have sleeved this wire. Nope, I just chose to do a whole bunch of heat shrink on there. Anyway, the 3 joints are under here. Phil actually showed me off camera the NASA approved method of how to twist the wires and then flip the ends back on themselves. I ended up doing it that way without pre-tinning the wire. That way you can twist it and then do it. So the other 2, I did that method. One of the things Phil pointed out too that we could have done that would have been even better and probably would have retained the air cooler is instead of having them point straight up like that, I could have stolen off of this EVGA 3090 the 90-degree connector like that. That's actually the fan connector. And then I could have probably left it on there full time and it wouldn't have interfered with the cooler. I guess I could always play with doing that later. The nice thing is, since they are a soldered through hole now, it'd be a lot easier to deal with than trying to get the solder out of the ground, which it was like stuck right in the center of the board. But none of that matters, because we need to see, I need to clean this up first to get all the flux off. Put my card back together, get it ready for LN2 session, and plug in and see if this connection is solid and works. I mean, it's pretty solid. I don't think it's going anywhere. Here it is, all plugged up, ready to go with the LN2 overclocking session. Got my wires plugged in right there. So I can turn this on with the pod installed and not worry about like any sort of overheating as long as I don't put it under load, because the thermal mass is so good. But wait for this to boot up. As you can see, maybe you can't from your angle, I do have voltage. So I didn't murder anything by letting it sit on the hot plate as long as it was. The temp wasn't anywhere near hot enough for it to have hurt anything either. I mean, think about how hot a reflow oven is, right? Then we're nowhere near that. See, there's my video signal. But we need to make sure that the EVC is able to see the graphics card, or the voltage controller. So I just need to select 12C1, because C1 is the port I have it plugged in. Click Find Devices. There it is right there, the MP29816, and there it is. So now we can see all of our temperatures, our VRM temps and voltages and wattages, and I have all my voltage control and stuff. So now it's a lot neater, although it's probably still gonna be in the way of putting the air cooler on. But I guess it's still nice to be able to quickly disconnect it if I need to. Maybe in the future I'll see if the right-angled connector will clear the cooler. If it will, then I'll just switch it to a right-angled connector. But yeah, that was a little bit of a pain in the ass trying to get the solder out of the ground hole, because it was kind of the opposite effect. Like once I'd started using the board heater, it's much easier now to solder in the ground because of the fact that I can keep the ground plane hot. So it's not like the heat is moving away from where I'm trying to solder. So I can easily get a solder ball in there or whatever and pass through and solder it up. The problem was the board's so thick, even when wicking, it was taking like pieces of the solder out of either side, but then in that middle plane, because it's a multi-layer PCB, the solder was staying very stuck to the middle. So we tried creating like a wedge shape, like a triangle piece of wick to get down in there, and I could get it to pull some, but I could never get it to go all the way through. It was a complete pain in the butt. What I was able to finally do was I have a drill bit. Hold on. Yes, I know what you guys are gonna think about. Jay drilling boards again. No, I didn't drill anything. I simply had a very tiny, like hobby-sized drill bit that was just the right size for that hole where I was able to kind of like just poke it through. Like the little paper thin amount of solder that was keeping me from being able to push the terminal through. So I was able to just sort of push that out while kind of turning the drill bit a little bit. It didn't drill into the plane or anything. I was able to push that out and then get the pin through. Now we tried everything, including heating the pin, putting flux and solder on the pin, trying to heat the pin and just sort of like hot knife it through. Couldn't get that to work. And you might be going like, well, if you're able to push a drill bit through, why didn't you just push the pin through? I tried that, but the pin is too flat and square on the end where the drill bit at least has a point. So it worked. I got to practice and figure out how to get the very center of the solder out when it was coming out both ends. I was literally adding solder, adding flux, adding solder, and building it up and creating like a solder ball to then hope that by wicking it, it would take the middle out with it. But it didn't do that. It would just continue to take out the top layers, but not the bottom layer. And I thought maybe that's because the board wasn't hot enough. Maybe those inner layers are not getting enough heat. That's why the solder's sticking there. I pushed the board heater up to 130 C, and I was afraid to go any higher than that. So this is where I would really like the experts watching this go on a hole that's only a millimeter big. And it's about, I don't know, it's probably a good 4 millimeters thick of a PCB. How would I whip that out of there? I tried using the plunger, the sucker. It didn't work. Like I just could not figure out how to properly wick that out of there. And I wasn't about to try and use the reflow station or anything like that to push the reflow gun or the hot gun to push the pin through, because there's so many other little things around there. I was afraid of blowing those off their pad, even though it was a really slow speed. I've already practiced moving some of those like 1/4 millimeter sized resistors back in place, and I can solder those now cleanly. I didn't want to do that with the 5090. Obviously there was a lot of risk involved. So I just chose to poke the hole, which is not the right way to do it. So please sound off in the comments below how to do that properly. But it's up and it's working and it's clean and it's looking a little less jank as we go. So anyways, thanks for watching, guys. Currently number 3 on the leaderboard. If that holds, gonna see what this card's got. Something's got to give, either the card or my willpower to continue trying. All right, guys, thanks for watching. Please give me some constructive criticism. I'm trying to be a little less triggering, but it's always going to be triggering. I'm sure you guys have seen those electricians videos on Instagram, or those soldering videos on Instagram, or there's, no matter how professional and good it looks like the person is, there's always those people in the comments that just know more and they're so much better. Yeah, you know, rage bait culture. It's just it now. We don't do that around here. So I will listen to the good comments and we'll just ridicule and make fun of the stupid comments behind the scenes.